In this video, we are going to look at the differential part of calculus. Now, under this video, we just focus on how to use the first principle to differentiate a given function or a constant. Now, under the first principle, we have this formula. So, first prime of x is equal to limit as h approaches 0 f open bracket x plus h minus c f of x divided by h. Now you only use this principle if you are told to use this principle, and remember, whether you use the rule, the power rule, the answer should always be the same. Now let's look at the first example. So let's differentiate the following. We'll begin by, let's say we have this function f of x is equal to 3. So we have just a constant, and we know that a constant, the derivative of a constant is always 0. So we write the formula f prime of x is equal to limit h approaches 0 f of x plus h minus c f of x over h. Now here what you need to do is limit as h approaches 0. This should be written here. Then where there is f, this one you substitute with the number if you are dealing with the number. So this is 3 minus, and we know that f of x is equal to 3. So here we put 3 over h. So if we continue, we have h approaches 0. 3 minus 3 is 0 over h. And we know that h into 0 is just 0. Let's have maybe, what if we have a function like this one, where we have a linear function. So f of x is equal to 2x. Now the formula is f prime of x is equal to limit as h approaches 0 f x plus h minus over h. Now the first step here, since we can see that we have the variable x, so we write our limit as h approaches 0. Then this time, what it means, where there is x, we need to substitute with x plus h. So this is 2 open brackets, then we have x plus h close. Then here, where there is f of x, we need to write whatever that the f of x is equal to. So f of x is equal to 2x, so we have our 2x, then divided by h. So let's see what we can simplify from here. So we are going to use algebra to expand. So our 2 multiply with x, the second one with h, and we know that 2 times x will give us 2x plus 2 times h will give us 2h minus 2x over h. Then from there we can collect the like terms. So we can say that these two are like terms. So say 2h plus 2x minus 2x over h. So limit as h approaches 0. We know that these two will cancel. 2x minus 2x is 0. So we have 2h divided by 2h. So we can cancel the h. Therefore, our final answer is just 2. And we can prove by using the power rule. We know that if we differentiate x raised to the power 1, we'll just remain with 2. Now, this time, let's say we have a quadratic function where we have f of x is equal to x squared minus 3x. Now, you can feel free and give it a try. So the first step, as usual, we are going to write the formula. So h approaches 0, then Okay, so our first step is where there is x, we substitute with x plus h. So we can see that here we have x squared. So we are going to have x plus h, then squared, minus 3, another x here, we put x plus h, then subtracted this subtraction here, then f of x is equal to this. So we write x squared minus 3x over h. Then from here we are going to expand. Since we have x plus h squared, so we are going to write two pairs of brackets. Then we can distribute -3 to x and h. So -3 times x will give us -3x. -3 times positive h is -3h. Then you also distribute negative to x squared. This will give us -x squared. Then negative to 3x will give us positive 3x over h. From there, let's expand the first pair of the bracket. So this x will multiply with x. The second one will have h, and we know that x times x will give us x squared, plus x times h will give us xh. Then the second one, the h will multiply with x, then number 2 by h. So x times h will still get xh, plus h times h will give us h squared, minus 3x. So this we can bring it here, plus 3x minus 3h minus x squared over h. From the first party, we have the like terms that we can add. So x squared, so these two can be added. So xh plus xh is equal to 2xh plus h squared minus 3x. So this will cancel, just cancel, so that one will cancel. So this will cancel. So that one will cancel, minus 3h minus x squared over h. Then from there we can see that these two are like terms, so we can group them together. So we have limit as h approaches 0, x squared minus x squared plus 2xh plus h squared minus 3h over h. Then we can see that we can cancel these. Then our expression continues. So we have 2xh plus h squared minus 3h over h. Now upon reaching here, what we are going to do is we need to factorize the numerator. So if we factorize the numerator, we know that from this and this and this, h is common, so we'll take out our h, and if we divide h into 2xh, we have 2x plus h into h squared is just h into -3h is just -3 over h. Now after we are done factorizing, we can cancel our h. Then from there we have limit as h tends towards 0, then 2x plus h minus 3. There is no over this time since we have removed the h. Now upon reaching here, we can now substitute where there is h with 0, since we are saying as h approaches 0. So this will give us 2x plus 0 minus 3. Then our final answer is 2x minus 3. So this is how you can differentiate a given function using the first principle. Now let's try one more. This time we'll say f of x is equal to x raised to the power 3. So we have f prime of x is equal to so we are saying where there is the x, we substitute with x plus h. So we have x plus h, x plus h, x plus h, since we have the power of 3, minus, now f of x is equal to this whole expression, so minus x raised to the power 3. So now how do you expand if 3 brackets? So the first one, first we are going to expand the first 2 brackets. So we know x times x will give us x squared plus x times h, that is xh. Then we move on, h times x is xh plus h times h, will have h squared times x plus h minus x raised to the power 3, everything divided by h. So from the first bracket here, we can see that we have these 2 like terms. So we have h, limit as h approaches 0. So x squared plus xh plus xh is 2xh plus x squared h squared times x plus h minus x raised to the power 3 over h. Then we are going to now first FOIL these 2 brackets. So multiply x times this x is x cubed plus x squared times h is x squared h. Then we move on to 2xh times this will give us 2x squared h plus 2xh plus h will give us 2 xh squared. We go to this one, so h squared times x will give us x h squared plus h squared times h will have h cubed minus x raised to the power 3 over h. So let's look at the like terms that we can add or subtract. So the like terms here is these 2 are like terms. So say x raised to the power 3 minus x raised to the power 3. What else? So we have this one and this one. So these 2 are like terms. So 1x squared h plus 2x squared h, we get 3x squared h. Then plus these 2 are also like terms. So we'll get 3xh squared plus h cubed over h. So we can cancel these 2. So limit as h approaches 0, we'll have 3x squared h plus 3xh squared plus h cubed over h. Now after we are done simplifying the like terms, we need to factorize. So from this part, this part, we can see that h is common. So h is common. So if we divide h into 3x squared, h is just 3x squared, plus h into 3xh squared is just 3xh. H into h cubed is just h squared over h. So we can cancel this. Then we have limit as h approaches 0, 3x squared plus 3xh plus h squared. Now after you are done factorizing and cancelling, you substitute where there is h with 0. So you have 3x squared plus 3x where there is h0 plus 0. Then you can see after you substitute where there is h with 0, this expression should not be written in the next step. So we have 3x squared. 3x times 0 is just 0. 0 squared is just 0. So our final answer is 3x squared. So to prove, if we want to use the power rule, we know that if we have f of x is equal to x raised to the power 3. So f prime of x, what you do, you move the power to the front. This becomes 3x, then we subtract 1 from 3. Then our final answer will give us 3x squared. So this is our answer. So I just wanted to give you like an introduction on how to use the first principle. So if you find this video helpful, please give it a thumbs up, and don't forget to share and subscribe. Thanks for watching. God bless you.